just going to give you just a quick introduction to how you use the chat box, because that's where you're going to put your questions, and I'll be monitoring. So actually had to just update this now because it changed. So, and I think it's actually simpler. What you're going to see on, and you may see some differences on your browser, so you get a slightly different box, but if you look up on your screen, you're going to see these three icons. You wanted to press the one that looks like a cartoon bubble. And you do that, you should get a box that looks like this. You may still get the old box, but basically you'll get a box, and if you have this one, you'll type here. If not, you have a top and a bottom piece, and you're going to type in your name. You know, you can type in whatever question. So to make sure that everybody's working, why don't you put your name and where you're from, and if you're coming as a group, I think I always like to know if it's a group. I saw a few people from Chappaqua, so I assume some of you are coming in as a group. Why don't you put in your name and your district, or if you're from the University of Southern Mississippi, your campus. Okay? Okay, so I think everybody got that, so I'm going to mute for quiet. Okay, so what I'm also going to, we have kind of a tradition when we do the webinars. We always, in addition to asking you where you're from, there's always like a quiz question of the day. And so this year I decided, last year I kind of had technical questions. I thought I would focus on educational office professionals in popular culture. So in each one of our webinars, what I'm going to be doing is showing you a picture of a office staff member from popular culture, and you have to try to guess who you think it is, okay? So here's our first one. Some of them will date you, so if you want to deny you know, that's fine. But from which TV show was this receptionist? So when you think you know the answer, and you get extra points if you put her name down, first name down. So when you think you know, take a guess. Okay, so I think everybody got it. Good. Good. And does anybody, actually, I think her name was Carol, but I could be wrong. Maybe I'm wrong. Okay? All right. So you all did good. Let's move on to our session. And again, I'm going to keep it as simple as possible. Let me, as just by way of an introduction, as you know, we have a lot of very technical tools today. We have Excel, you know, and certainly we have calculators. But I would argue they don't really do you very much good if you don't know how to organize the questions themselves. So even though some of the things that I'm doing here you can certainly do in Excel, you know, if you really don't know the underlying math, you're going to be a little limited. So our goal here is to try to go over some of that underlying math, nothing too complex, what I would all call this first order math, the kind of things you're likely to see in an office or in everyday life, but and on the practical side. No arithmetic, strictly, I'm assuming all of you have calculators, so we're not trying to quiz you on how well you were able to do arithmetic, but more that you're able to organize the problems. So let me start with the first one, and by the way, when I began doing my work with Navy, and this, I promised the folks that I assumed they knew nothing. And that made people feel much, much better, even though it turned out they knew some of this. So one of the things that's really important for us to be able to do if we're going to work in calculations is to understand our decimal system. And so my first question is, which of these is the smallest number? So when you think you know the answer, you can put it in the chat box. And then I'll show you an easy way to do it. Okay? It's good. Okay. And then you can certainly also answer which is the largest one. Okay, so one of the things that makes this a little hard is because of where the digit, as you know, in our number system, it's all about placement. So whenever I have a problem like this, the easiest way to solve it, make it so visually easy, is to simply line them up vertically. If you line them up vertically, it becomes very easy to see what the answer is, okay? So in the first one, the answer is, D, as all of you, most of you, all of you selected. And here again, if you line them up, it becomes very clear the answer is B. So you all did very well on your first piece. Let's move on, and we'll move quickly if something is obvious to folks. So let's go on to our next piece. So this is our classic number line. It's interesting. I'm sure when you grew up, you learned about the Roman system. It was nightmarish. Every time I see a movie with Roman numerals, it really takes me a hard time trying to figure out what year it is. So our number system is based on its placeholder position in relation to the decimal point. And in fact, numbers, and I think you all know this, numbers to the left of the decimal point represent increases of 10. We're working base 10 in our number system. And then anything to the right would be for tenths, fractions of tenths. So tenths, hundredths, thousandths. The middle is actually the decimal point, and that actually represents ones, but for physical space, we put it right to the right of it. So if you really wanted to be technical, you could say the dividing line is the dot, okay? And it's all by placement. So what I want you to be able to do, because it's essential to rounding, is to be able to identify the digit. So in each one, and you don't have to answer all of them, but in this one, say in A, the digit's going to be, that's a what? That's a tenth, right? And here, it's a tens, because it's units, ones, tens. And here, anybody want to guess on C what the answer is? Anybody? When you get it? And of course, sometimes people have a good ability to visually do it. Sometimes you just got to count it out. But what digit is this? Nobody? Everybody's not brave enough? So we'll do it together. Tens. You all can hear me, right? Got to tell me you're alive. Yes? Okay. Okay, good. Yeah, sometimes I get a delay on the so it's tens, hundredths, thousands, 10,000. So you are correct. And then here it's what? Tenths, hundredths, thousands, 10,000ths again. Okay, good. So everybody's got that. So why is that important to know? Because the next thing you have to do is related to that, and that is rounding. Okay? So there is a difference between truncation and rounding. Truncation is really where you just cut off the digits, but we have a rounding system that we apply, and it's based on a set of rules. If you think about it, there are 10 possible numbers, including 0. 0, 1, 2, 3. There should have been a 2 there. I apologize. 1, 2, 3, 4, 5, 6. I don't know what happened there. So if a number is between 0 and 4, then it's closer to the 0, to the previous number. If it's 5 to 9, it's closer to the next number. So when we round, what we do is we identify the digit that we're rounding to. And again, the answers are here already, but we're identifying the digit. So if we're rounding to the nearest, say, tenth, so that's the 10th digit. You then look to the digit to the right of it, and you decide whether or not that's greater or less. And did I get that right? Let's see. No, actually, I think I might have that wrong. Oh, yes, that's correct. Okay? So what you're going to do is you're going to look at the 8. You're going to look to the digit to the right. That's between a 5 and a 9, and therefore you round up, and this becomes a 9. Everybody clear on that? And again, I don't want to bore you by doing the obvious, but you all know how to round all of these, and everybody's clear on rounding? Yes, no? Tell me yes, or I've got to assume and go over them. Any questions? We're good? Good. All right, I promise number 6 doesn't look right. Okay, let me look at number 6. So it's to the nearest hundredth. Okay. So if it's to the nearest hundredth, You're right. It should be just 365. There's no other digit beyond the hundredths. Right. Well, wait a minute. Tenths, hundredths. No, it is right. Okay. So, I'll just pull it up again. So the first thing you always have to do is identify the digit. So the digit is, oh, I see what you mean. Yeah, it should be 26, not 36. Correct. All right? Or 24. Right. Because this is the 4. All right, good. You got eagle eyes. All right, you're all great proofreaders. I stand corrected. So let's just talk about, part of math is kind of it's almost like a notation system. And so part of what you need to be able to be successful in math is to know what each of the things mean. And of course, we learned this in elementary school, but I want to talk about some potential problems for folks. So the first thing I want to talk about is some differences between the way we identify numbers in the language and the way it's handled in Excel. For those of you who work with Excel, how many of you work with Excel from time to time, by the way? Anybody work with Excel? Just say yes. Okay, good. All right, so in our traditional number system, we had plus, minus, multiplication, and division. So the plus and minus remain the same in Excel, but in Excel, because it treats text as a different item, X is replaced by a star, and that star is the star that appears above the 8 on your keyboard. And the division sign, there isn't even one of them on your keyboard if you want to use it, is a slash, which is just another interesting thing. So I wanted to focus a little on division, okay, for a minute, and notating division. So there are lots of different ways of showing division. So you could say 10 divided by 5 and write it this way. You could write it this way, 10 divided by 5, and this is really significant because anytime you encounter a fraction, fractions are essentially division problems. So 10 divided by 5 is 2, but that's actually what looks like a fraction is also a division. So this approach is fine because we're going to tend to put it in a calculator or Excel correctly. We're going to put in the 10 first, and then you're going to use this symbol divided by 5, or if you have it this way. But when people get to this one, we have all kinds of problems. And if the whole language you use, is weird too. So they'll say 10 divided by 5, they'll say 10 divided by 5, they'll say 5 into 10. How many of you have heard that? So a lot of people have problems with this because they put the digits in wrong. So the 10 is the numerator and the 5 is the denominator. And I think the reason they did that was so that we could do longhand math this way. But interestingly enough, in Europe and in parts of Latin America, they've solved the problem. Look at what they do. They write it like this. They still do the same longhand math the same way, but by writing it this way, they're still functioning within left to right. So I just wanted to bear that in mind. We rarely see too many of these anymore with longhand math, but I just wanted you to be aware of that because I know that fouls up some of my students in the early days. Okay. So now here's your first math problem, challenging math problem. So what I want you to do is figure out what the answer to is to this problem. And when you think you know the answer, type it in. Okay, Gail, you got to check again. It's definitely not 42. That would have been none of the answers. Okay? Ooh, this group's good. You guys are good. I didn't catch you. Okay, good. Well, the answer actually is 17. But from time to time when I do this, I get people giving the answer of 22. And the reason they give me 22 is they'll go 5 plus 2 is 7. 7 times 6 is 22. Okay? The problem with that is they don't understand this notion of order of operation. And again, depending on when you went to school, you may have learned this. Anybody learned this? Please excuse my dear Aunt Sally. If you heard that, tell me yes, so I know. please excuse my dear Aunt Sally. I want to make sure they do it in Mississippi and in New York. But anyway, so that really represents parentheses, exponential, all parentheses are, exponents, multiplication, division, addition, and subtraction. Now, actually, these tend to be pairs. It's rare that it makes any difference what order you do, particularly on multiplication and division, but it kind of works this way. So, using the order of operation, when we don't have parentheses to indicate otherwise, then we'd always do the multiplication first. So you do 2 times 6, which is 12, plus 5 is 17, and that is the answer. Okay? Now, if it was your intention to have it be 22, then you would write it this way, and you would put a parentheses around the item you wanted done first. So if you did 5 plus 2, equals 7 times 6, you would get 22. Okay? So here's your first task, and again, you don't have to do all of them, but maybe just do a couple of them, and make sure that you get the answers right. So I would recommend you do, at a minimum, do number 5, and, do number 8. Now, with 8, my recommendation is that you take your calculator out and convert each one to a decimal, and then write the answer. Give me a decimal answer. Same thing here, even though a lot of you could do it visually. Okay, so don't give me a fraction answer. Give me a decimal answer. Okay? So let's do 5 and let's do 8, okay? And 5's basically the same as, okay, that's correct, Gail. And number 8? I want a decimal answer, though. So, Jessica, what's the answer as a decimal? Just divide. 5 divided by 8. There you go. There you go. Because just remember, there's no fraction numbers in Excel. So if you encounter a fraction, you're going to need to convert it to a decimal anyway to be able to manipulate it anything on a computer. Okay? And that is correct. It's 0.625. Correct. Okay, good. You're all doing really good. Now, sometimes I don't want to get very long-winded about fractions, except to say that they're kind of becoming an outdated notation. The reason for doing fractions originally was that you could manipulate smaller numbers. You didn't have to deal with 3, 7, 6, 5, 2, 8 in a time before calculators. But you had to know a lot of rules. So there was a different rule for addition, there was a different rule for multiplication, there was a different rule for division, you inverted and multiplied. So, if you just convert them to decimals, you avoid all of that. So, and anyway, since most of the things we're going to need to do, we're going to enter in computers, you're seeing less of them. The only ones you really see anymore are what are defined kind of as aliquot parts, which are these very common fractions that people know in their head. So you see 1/8, 1/4, 1/2, but sometimes you'll see 1/3, but you're not likely to see like 6/10 or 5 8/10 anymore in any kind of reporting. That's just not done anymore. And so again, here are all the answers. And again, when you have the recording, if any of you want to check yourself, you can do that if you want to do them later. Okay. Converting from decimals to percent. And again, this is pretty simple stuff. It's not rocket science, but you'd be surprised how many times people get confused on some of this. When I was teaching, I used to tell my students that all they had to do was memorize DP. 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 So can you all help me out here and just type in the words DP, the letters DP? I'm helping you memorize. DP. DP. Good. I used to go around the room and make everybody do this. And here's why. If you lay it out, because we work from left to right, if you lay it out, you'll always know what direction you have to go. So if you have a series of decimals, you always know you have to move 2 places to the right. So this becomes 6%. In the case of the second one, remember, what do we do with any kind of a division fraction? We do what? We convert it first. So if we take 2 divided by 8, we're going to get 0.25. Once we take, but that's 0.25, that is 25%. Here again, this is 11%. This one always throws people off because they have this major habit of if it doesn't feel right to them, they don't do it. So you're going to move 2 places to the right, so this would be 120%. And again, here are our answers. Okay? So remember, you write the decimals first. You never can get confused on the order. People have a little problems with this one. Okay, so if I have a series of percents, now you can also do it mathematically. You can times your answers by 100 and just simply get rid of the decimal point, and that will work the same way. Okay? So when we have percents to decimals, we still remember dp, but I simply write the decimals on the left, on the right, and then I move the decimals. So here we have 16%, that's 0.16. We have to move 2 places, so that's going to be, we're going to move, I put it up already, but we're going to move 2 places, 0.003. This one throws a lot of people. You convert the quarter, you get 0.25, but that's 0.25%, so you've got to move 2 places over. That's going to be 0.0025. 140% is 1.4. I actually don't need this digit. And 0.4. Everybody clear on all of those? Again, nothing too deep, but everybody good? Good. Glad to hear it. Okay, moving right along. The quicker we go through the basics, the more of the fun stuff we can do. So now we get to algebra. Ooh, the dreaded algebra. But actually, especially simple order algebra is a very simple concept. The best way to really understand algebra is to think about a balance beam scale, okay? With the equal sign being the scale, so to speak, or the balance beam of the scale. Okay? And in fact, these scales are extremely accurate. And so in the days before they had digital scales, which today are even more accurate, if you were involved in measuring things, you know, the delicate measurement, for example, like you were, say you're a goldsmith, you were a jeweler where you were buying gold or silver where, you know, being accurate matters because you're paying a lot per ounce, you know, then what they would have is a scale like this and a set of pre-measured weights. And the pre-measured weights were of different ounces, different amounts. And what you would do is place the appropriate weight on one side and place whatever you wanted to measure on the other. And as soon as they balanced, then you knew that was the weight of the item. So if you were looking for an ounce of gold or 2 ounces of gold, you'd put a 2-ounce thing here, and then you would, you know, pour the gold or whatever you were pouring until you really received that amount. Same thing if you were measuring food. Now, of course, our digital scales work differently, but that's the basic concept behind a balance beam scale, and that's how an algebra problem works. So here we have a very simple algebra problem, because simple is good in terms of going over content. So what we have here is 2x equals 20. So all of you could do this in your head. I realize that, but again, just to go over the basic if you haven't learned it in a while. So we're always looking to get the x by itself and the number on the same side. So this is like our balance beam scale. So the rule basically, just like in the other scale before, I'm going to back up. If you had a whole bunch of weights on this side and you wanted to balance it out, whatever you took off one side, you take off the other, you're going to get an equal balance. So here, whatever we do to one side, as long as we do it to the other, we're going to get the same results. So here we have 2x equals 20. In order to get the x by itself, if you have 2x, you got to divide by 2 to get 1x. 2x means 2 times x. So we're simply going to divide by both, right? And we're going to get our answer, which is x equals 10. So you all remember this from school? You're all good on this? Yes? No? We good? Okay, good. Oh, okay. All right, so let's do a few. When you think you know when you think you know the answers, put them in. These are fairly easy. They shouldn't take you too long to do. Okay. Okay. Number 2. Anybody want to take a shot at number 2? Yep. Number 2 is 10. Good. Number 3. All right, I think we're good. Except number 3 was 5, because you have to take the -5. That turns this into a 10, and that's 2x equals 10 equals 5. Okay? Everybody okay? Got it? That's number 3. All right? Let's work out. You want me to work it out? Okay. Let's see if I can annotate and do that. Okay, I'm going to try. So I have to put a +5. Oh, you're right. I'm sorry, it's a -5. You were right. Ooh, right. So that becomes a 20, and then it is 10. Whoops, I messed up. So you're right. It is 10. The answer should be 10. You're better than I am. Okay. All right, moving right along. I only teach it. I'm not good at it. No. All right. So what we have is classic percent problems. And so far, all the stuff we did was pretty basic. You might not even see it on the job. But now we're kind of going into the zone of the most common calculations that you tend to do in offices, which are problems related around percentages. And every percentage problem is based on this basic formula, which is base times rate equals portion. And so in each one of the equations, we're going to have a situation where one of the items is missing. So we're either going to know the rate and the portion, and we have to find the base, or we're going to know the base and the portion, and we're looking for the rate, or we know the base and the rate, we need to look for the portion. So we'll always have one item missing. Okay? So I'm going to show you, here are all the formulas for that, but I'm going to show you a little trick that one of my colleagues who's a math teacher showed me a lot of years ago, and I really love it. I'm going to try to annotate this and show it to you. What she said is, if you want to know the formula for any missing item, cover the item. So, for example, if you're looking for the portion, you want to cover the portion. Cover that one. If you cover that one, then it's base times rate. And so to find portion, it's base times rate. If you want to find the base, you cover the base. And so you have portion over rate will give you the base. Portion over rate will give you the base. If you want the rate, you cover the rate, and it's portion over base. Now, I could certainly do the algebra behind each one of these, fairly simple algebra problem, but once you kind of know this, if you know this, I'll say pie chart, you really know how to solve any of these problems. So everybody clear on that, or I need to go over that again? You want to see it again, or you got it? One or the other. Okay, good. All right. Because what a lot of people have, I can't even tell you how many administrators call me up, and they say, look, I need to figure out what % of my students, were absent, and they're asking me which number goes in the calculator first. Okay? So the key to being able to answer a lot of those kinds of questions is being able to know what you're missing and what you need. So we're going to look at a few problems that involve percentages and, and how you might solve them. Hold on, I've just got to shut off my annotation tools. It's fighting me. So hold on. Okay. So we have a few problems here, and these are still fairly simple because what I have done here is to lay them out for you. And what we're going to do in our next step is kind of do them where they're not laid out, where I'm giving to you as a kind of a word problem. But why don't we just start with them laid out, okay? So if you're looking for the answer to the base, right? Remember, you're going to take the pie chart, and you're going to go, if you're looking for the base, you're going to go portion over rate, which I've given you here, right? So the portion here is 312 divided by the rate. Now, since the rate is provided as a decimal point, a percent, you have to convert it to a decimal to put it in your calculator, and you're going to get 832. So can everybody at least try that? Make sure my math was right. You got it? You're all working on it? I'll do it also. How's that? I have my calculator handy. Okay, so the first one's correct. Second one's a straight, kind of straight function of the application, and that one's pretty easy. Okay. And then the third one, again, this is one where you just need to know what goes in what order, okay? So you can either remember these three formulas, which I pretty much do, or you can just draw yourself the little pie chart, remember the chart, and you'll always know the answer to how to solve any of them. Okay, so I'm waiting for the answer to the last one. Then that is correct. Good. All right? Everybody good on that? Now, it gets a little complicated when we get to word problems. Some people go, oh my God, word problems! So there are really two ways of handling, in the general sense, word problems. One is by syntax, and the other is by context. So sometimes you can figure it out just by syntax because we know that certain words in English have a translation in the language of math. So, for example, plus, minus, times, is, of are all, representatives of symbols in mathematics. So if you get a problem like 5 times 20, you know it's multiplied by 20. When you get a problem like this next problem, okay, you can do it by context, by our understanding of the nature of the thing. So, for example, most of us understand that when you have a sales tax, that sales tax is going to be applied to the price of the item. So it may not be in the, it'll just say there's a sales tax rate, but we know that the base in this case is going to be the 50 and that the sales tax rate is going to be, 8 1/4. We have to convert that to a decimal. And then we need to know what you'll pay in sales tax and what is our overall cost. So as I'm about to move to my next slide, I'd like you to, and actually I'm continuing to get this dot here. I'm going to see if I can get rid of it. I think I have to clear all the annotation and just take it off. There we go. All right. So this is actually how you do the formula. You're going to do the base times the rate equals the portion, and then you're going to take the base amount plus the portion, which is the sales tax, and you're going to get the total. Is that clear to everybody? And I'm sure you all know how to do this, right? So I want to show you a little tricky shortcut, okay? That really can save you a lot of time. You have to do a lot of these. So I want to talk about an idea, okay? And here's the idea. It's kind of hard to describe on the screen. I think actually I did put it up, okay? So I'll put it up and just show it to you, okay? So the 50, which is the base, right? So what you're going to do is you're going to take the base times the sales tax rate, right? And so if you think about it, the base is 100% of the price, right? And you're going to add them together. So if you have a sales tax involving, say, 8 1/4, instead of multiplying by 8 1/4 and then getting the answer and adding, what I can do is multiply by 1 plus 8 1/4 with the 1 representing 100% of the base. I'm going to go right to my answer. Now, you normally would not write it this way. You'd write it like that. But anytime I get a sales tax rate and I have to figure out what it is, let's say the rate is 8 1/4, I'll do 1.0825 in my calculator. I'm going right to the total. Okay? So were any of you familiar with that? Because it saves a step. Yes? No? So we have another kind of problem, and again, where you need to know context, right? So John is planning a business trip that involves traveling 1,200 miles. If John gets 15 miles to the gallon, what will it cost him for gas if the average price is $2.29 per gallon? So the first thing we have to do is figure out how many gallons he's going to need to use. So what we have to do is take the total miles, and I purposely made it a round number. They don't always come out that way. And that's going to be 80 miles. Once you know the 80 miles, you then can times it by the cost per gallon, and that's going to give you your total price. Okay? So everybody clear on that one. And again, I know it by context. I know that if a car gets 15 miles per gallon, I've got to divide by the miles per gallon to get the answer. Everybody good? So here's a tricky one. Okay, so 1/4 of a district's employees are male. If the district employs 1,600 persons, how many are female? Okay, so the first question, because there's a two-step question, is what percent of the employees are female? When you know the answer, write it. Okay, so let's make sure we're answering. You're all going right to the answer. So what percent are female? Correct. Okay? Correct. And so once you know what percent are female, then you can simply multiply 1,600 times female. What throws people off is I gave you the number of the percent for male, but I asked you for the percent for female as the answer. How many females? So this is called a two states of nature problem, okay? And it's kind of a basic percentage problem, but it's important to know. Whenever you have a situation where there are only two choices, if you know what the percent is for one, you can figure out what the percent is for other, and I'm not going to talk about gender confusion here. Let's assume we're going to leave that out and stay out of the politics of that. But, you know, the example would be, you know, if we have the students in attendance, we can and we know what percent that is, we can determine how many are absent, you know. And so anytime we have only two choices, you can infer the results of the other one if you know the percents. And again, this is how you would do that. Okay, and you can go right to the answer. So now we're just going to take it to a little bit of a different level to make sure that you really know how to do these types of base rate and portion problems. So it says of the 300 students in our school, enrolled in our school, 40 were absent. What percent of the students were absent today? So here you have to be able to determine what is the base and what, well, first we have to figure out what's missing. So obviously a base rate, this is fairly easy. Of base rate and portion, what's missing? What's missing? And it told you in the question. It said the percent, the rate, right? And then the only question is which is the base and which is the portion, right? No, actually what's missing is the rate. We have the portion, okay? So the base is all the students, right? And a part of those students are absent, so that's the portion, right? So our base is 300, our portion is 40, and then we have to be able to figure out the rate. And again, I kind of did it here for you, right? So how do you know what is portion and base? Well, you can, try to think of it in terms of parts and wholes. Think about which part was the whole. The 300 is all the students, that's the whole. The 40 is the part. And then once we have that, then it's fairly easy. Remember, we always said we cover the one we don't have. So if you cover the rate, you're going to get portion over base. And that's going to be 40 divided by 300. It's going to be 13.33. So everybody good on that? So the challenge in those problems is figuring out which is the base and which is the portion. Okay. So now, again, it's an interesting thing. If we know this is, again, another one of those two states of nature problems, right? If I had asked what percent of the students were present, I could have certainly recalculated that. I could have done it with the amounts. I could have said 300. If 300 is the total, 40 are absent. There are 260 present, and taken 260 as the portion over the whole. Or I could have said, hey, there's only two states of nature. You're absent or you're present. If I know 13.33 is the percent that were absent, then logically 8.7 are going to be present. And you could do it either way. You would have gotten the answer. So let me stop. Everybody clear on that? Anybody need me to explain that more? So you got to tell me one way or the other, because otherwise I don't have any feedback. I can't look in your eyes and see if you're confused. All right. So this is always going to be the struggle, knowing which number goes in first. And even though the technical terms are parts and base, I often think of it as parts and whole. What is the whole? And you'll pick that up and infer from the language of the students, meaning of all the students, of the people enrolled, right? You know, of all the buses we ran, what percent are, broken? So usually that, that's going to be your base, okay? All right, so now we've got another question like this. All right, so it says the transportation department is currently serving 40 students. All right, is currently serving 40 students attending private and religious schools. This represents 5% of all our riders. So 5% of the students attend parochial schools that we're transporting, and that's 5% of our students. How many students does the department transport overall? So I'd like you to figure this out. So the first thing you have to do is determine what are you missing. So when you know what's missing, just write the word. Are you missing the rate, the portion, or the base? Okay, so we're missing the base. That's correct, and you went right to the answer, Tammy, and that is correct. Okay? We're missing the base. Why? Because we know the part of the students that are attending private and religious school. What we need is the overall, the total students. So we have the portion, which is 40, and we have the rate. So when we're missing something, remember what we said? I don't have the chart up again. We cover the item we're missing. That's portion over rate, and your answer is going to be 800. Okay? All right. It takes a little time to get practice in this, but this is really the essential skill because the problems get defined this way, not with charts. You're asked what, things like that. So we're going to try a little bit of a different problem here. So before we dealt with a sales tax, which was added on, but we also deal with something called discounts. And you might think, gee, I work in schools, there's no such thing as discounts. But actually, in talking to the business office, they deal with discount situations quite a bit. So, for example, if you got a savvy principal in your building and they're going to take a whole bunch of kids to the zoo, you can bet they're going to ask the zoo for a discount because they're coming in a group. Or they may just offer it as a discount to a group. So here we have a scenario where it says our local zoo offers discounts for schools and not-for-profits who take a group of at least 20 to the zoo. The regular admission is $5, but our school district gets a 40% discount off of the regular price. How much would the district pay for 60 students to attend? Okay? So there's a couple of different ways you could lay this out. You could first figure out the total, or you could figure out what the discount is for each student. And I've got a couple of ways just of kind of laying this out, right? So one way you could do is just say, okay, we have $5 times 40. That's our discount, is $2. We're going to take that discount off of the price. That's $3. 3 times 60 equals 180. So that's certainly one way of doing it. Another way of doing it might be to say, and this is a little bit of a shortcut, if we're getting a 40% discount, then we're only having to pay 60% of the price. So just like when we had sales tax, which is added onto the price, we did plus 1 plus 100. When we have a discount, we take it away from 100. So the full price is 100 minus 40%. That means we're paying 60% per kid. We save it. We can do it in one step. And then at that point, we do $3 times 60, and we get the 180. There are other ways we could have done it. We could have done the total and then done this first, okay? But just this notion of when you're working with discounts, if you know you're getting a 40% discount, you're paying 60% of the original price. So now it gets a little tricky when you get multiple discounts. By the way, multiple discounts, you don't see them as much in schools, but you do see them occasionally. Have you ever had a situation where a store will say, you get an additional 20% off your 40% discount if you use your store card? Anybody ever heard of that? Yes. Well, I have to. You're the only one? I guess you're the shopper in the crowd. Okay, good. Thank you, Diane. Okay, so a lot of people get confused by this. They don't realize that they're not really getting. Because people think, oh, gee, I'm getting a 40% discount, then they're giving me an additional 20. That's 60%. No, actually, it's not. Because they're giving you a discount on the discounted amount. So I've kind of calculated this out here, okay? And I kept the number so obvious, right? Because if it was a 60% discount, you'd be paying 40, okay? So if it's 100 times 40, that's 40. 100 minus 40 is 60. But when they apply the second discount, they're not applying it to the 100. They're applying it to the 60. So instead of giving you 20% of 100, they're giving you 20% of 60 off. So you're discount is actually 40, the total is actually 48. And if you want to know what you're actually paying, then obviously you would divide, what the actual discount was. You would have to subtract the 100 from the 48, which would give you what? 52. And that was the actual discount. You didn't get 60. Okay? So there is a little bit of a way there's a trick to do these. Okay? And to do this, the first thing, it's already an idea we learned about. Remember in the two states of nature problem, we said if you know what the 100% is, and you know what the 40 is, the other is 60. So there's a term for this in math. They call it complements. So if you have a 60%, 40% discount, the complement is 60. Okay? And again, that's a way you can do a shortcut. If you have multiple discounts, right, what you do, and this actually should be, what you can do is go right to the answer, is you can actually take the complement of the two and multiply, and that'll tell you what the discount is. And again, I just laid it out here. Okay? So if you want to go right to the discount, you go 100. The complement of 40, remember it's 40 and 20 was 60, times the complement of 80, and that gives you right to your 48. And clearly that's a little bit different from. So watch out for multiple discounts. They're not the same as taking the two discounts and putting them together. And again, if you were paying 48, then your discount actually was 52%. Everybody clear on this? I know I'm going kind of fast because I want to cover one more thing. All right? Okay, so we learned about straight percentages, base rate and portion. But another kind of problem that you're going to face are percentage change problems. And a percentage change problem, they're not really different arithmetically. They're actually very related, but I recommend thinking of them as different, okay? And so that you don't get the two confused, let me see if I can lay it out in a way that makes some sense, okay? In a straight percentage problem, you're comparing something to something else. So, for example, we're comparing our total number of students to the portion of students who are absent, or our total number of employees to the ones who are female. So we're comparing one thing to another. In a percentage change problem, you're comparing something to itself over time. Okay? So there's always a factor of time or of a changing event. Most of the time it's time. So the classic one would be, well, you received, we paid this much for something this year, and then the price went up, and what did we pay the next year, and by what percent did the price change? Or how did our enrollments change from one year to another? So how many of you have done or been asked to do a problem or a table that involved doing percentage change? We had to compare one year to another, a time period to another. Anybody? No? Yes? Okay, good. So where a lot of people really get fouled up in this is that order really matters. Okay? If you get your periods wrong, you not only get, oh, by the way, a straight percent is always going to be a positive number. A percentage change could either be a positive number or a negative number. So you could have a percentage change that's minus 5% or plus 10%. You'll never get that on a straight percentage. It's always going to be positive. Okay? But here's where people get fouled up here. If they get their periods wrong. Now this is really a base and a portion-based problem. So it isn't unrelated, but the question becomes, what's the base? And it's always important that your starting period is your base. So you're going to take so for example, if it was years, it would be 2018 minus 2017 divided by 2017. If you switch them around, not only will you get the order wrong, but you'll also get the percent wrong. So here again, we have some examples of percentage change problems. Now, whenever I lay them out, I like to lay them out so I'm less likely to make this mistake. Okay, so I'll always put my later period first. Okay, so I'm going to take 225 minus 195 divided by 195. So would you try to do at least one of them? By the way, the change is just the this number minus this number, and then you do the percentage change. So why don't you do at least one or two of them, okay? And then we'll see how we do, okay? So you ready? You want to see the answers? Okay, and now to the final results. Everybody still awake? Or you're calculating? Now you'll notice in the you'll notice that in the first one, in the last one, I've got a percent. You can actually do percentage change on percents. You just treat them as numbers. And by the way, being alert to your answers will help. I would expect that if the price went up, I'm going to have a positive change. If I saw an increase. If I start seeing a negative number here, then I'm thinking, oh, gee, I put it in the wrong order. Okay? But notice in each case, the denominator is year one. It's the earlier time period. So let me know when you want me to go on. Are you calculating away? Still calculating? Okay, moving right along. So here, first let me go. So this is a classic percentage change problem. I only have one more thing to show you, okay? All right. So here we have a slightly different problem. This is what's referred to as a proportion problem, okay? And actually, this is the way some of these things are done. I did a lot of this when I worked in accounting, okay? And that is where we are going to share based on something. So, for example, the most common one that you see in accounting is we're sharing the cost of, say, heating in a building based on square footage. So depending on how much each department has as square footage, they have to pick up the cost of, of the heat. And in fact, I had a situation with like a BOCES type agency in Connecticut where they had a printing department and they had staff in a mail room, and those were chargebacks to the other departments, and it was based on the income revenue of each of the departments. So each year I would have to figure out the proportional revenue of the departments and then calculate what each one's responsibility was. So here I've laid it out as a table. I'm going to take you through all of it. So first we have to, and there's actually two ways you can do it. Okay, so what we have to do is figure out what portion of each one of the districts would have to pay for a $300,000 service based on their enrollments. These enrollments are kind of high. Obviously, I made up some big numbers, but let's assume these are their enrollments of students, okay? So the first thing that I have to do is to be able to figure out how much each one is a percent of the total. And I'm sorry, I truncated a little bit on my table for that last item. I'll just move the column over, drop, because I'm losing a digit there. There we go. All right, so I'll put it back up again. So what I need to do is I need to figure out, if I want to know what each one's going to pay as a portion of the total, I know that 200 is the total enrollment for the area, say for all my districts that are involved in this service, and this district has 600 of the 200, that's 30% of the students. Therefore, they're going to have to pick up 30% of that, cost of the service, okay? And again, I'll lay out kind of the next thing. The next step is you just put up the 300, and then what you're going to do is multiply what each person. So Harrington, these are made-up school districts. A couple of them we actually have, but Harrington is going to have to pay $90,000 of the 300. Okay, so where am I getting the 200? The 200 represents the total of all of these enrollments. So unless I made a mistake in the calculation, it should be 200. Okay? All right? So, and then I'm figuring out the percent each one is of the total. So this, again, is a base and portion problem. The portion of all the total enrollments based on the whole region. So 30% of all the students are coming from this district, etc. And then I'm gonna multiply by that amount we have to evaluate. And by the way, this is, for those of you at USM, this is a very common way within a university for them to determine the cost per department for things like grounds. They'll base it usually on square footage, not on a number of students involved, but they'll do it based on square footage for each department. And that's how you just keep track of what it costs, Okay, or even security is done that way sometimes, Okay, so now there's kind of two ways you can do this. What I did here was I calculated the portion of each item times the base and calculated the percentages, but there's actually another way you can do it. They come up with the exact same answers, so I'm going to show you this other way. So what I do instead is I figure out what the amount of money is, and I say if there are 200 students, then each student is what? $1.5, right? So instead of doing the percentage for each item, I calculate the cost, the per enrolled student cost. So 200 students spread over a $300,000 cost of service means it's $1.50 per student. And then at that point, I simply calculate and multiply. I don't know why I got these extra zeros here. They shouldn't really be there at 60,000, but. And then I simply multiply by the number of students, and I'm going to get, as you'll see, I get exactly the same answers as I got before. It's just a little bit different way of doing the proportion. And in fact, in this last slide for today, as you see, I've done the two side by side, and you'll see they produce the same results. So here I'm doing it by proportions. The other way I'm doing it per student, but I'm still arriving at the same answer. So I'm going to stop here. We're kind of a bit over, and I'm going to unmute actually and see if anybody has any questions on anything before before we wrap up for the day. Okay, everybody good?
Yeah.
They're all calculating away?
We're good.
Okay. All right. So I want to thank you all. I know there was a little confusion over the order of the sessions. There were a couple of factors with that. Part of it, to be honest, was a little confusion between me and the University of Southern Mississippi. I originally gave them the dates, and then they posted different topics. So I will be sending out the order to everyone so we're all clear on what's happening when. But all the topics are going to be done. So we're not changing any of the topics I told you. It might be in a slightly different order. Cause any confusion. I hope you found it helpful. Certainly the recording will be available. I'm going to render this recording, and I'll have it uploaded certainly by the weekend, and send you